Welcome to the second part of question set number 6 solutions. Accidentally pushed stop there in between this question and the previous one. So in this question we're given a whole load of information. We're giving a triangle. The writing down here normally just tells you what's in the diagram. So let's just go through it. ABC is a triangle, yawn, we can see that. ACB is 90 degrees. That's ACB. Okay, that's this 90 degrees they've put on here. P lines on the line AP, well, we can see that here, and CP is perpendicular to AB. So CP, that's this right angle here they're telling us, and of course there's a right angle there to match it. What's the question? Well, prove that the angles of APC are the same as the angles of triangle CPB. So this is a proof. We're going to have to give a series of statements that take you from one to the other. So let's start out. So let's call that angle X. So angle PCB equals X. Therefore, angle PCA is equal to 90 minus X. And so that's 90 minus X. Alright, now let's look at this angle here now. So we know that's 90. So angle PBC. Well, we know the whole thing adds up to 180. So if we want to find this angle here, we take 180, we subtract the 90, and then we subtract the X, which equals 90 minus X. Okay, so we've got this one here, this is 90 minus X. Now over here, let's work this one out, angle PAC. So again, this triangle here, angles add up to 180 degrees. So if we want to work out this angle, we start with 180, we subtract 90, and then we subtract the 90 minus X. Okay, so 180 take 90 is 90. And then this minus sign is minusing both things in the brackets, which means it's minusing the 90, but it's minusing the minus X, which is the same as adding the X. So angle PAC is X. So there we go. Therefore, angles are the same in APC, that's this one, and CPB. Okay, simultaneous equations. So first of all, I'm going to solve this using elimination. I'm trying to make the y's or the x's the same, and I'm noticing that there's a connection between the two x's here. So I'm going to call this equation 1 and this one equation 2, and I'm going to multiply equation 2 by 2, so I've got the same number of x's in both. So if I do that, it gives me 4x's minus 6y equals 38. So I've multiplied everything by 2, and the top stays the same. And now I'm going to subtract. Why am I going to subtract? Well, I've been planning. My strategy is to make the x's the same, and the point of making the x's the same is to eliminate them, to get rid of them. And I know if I've got 4x and I subtract 4x, I haven't got any x's left, so they're going to disappear. So that's why I'm subtracting. So plus y minus 6y is going to give me 7y, and 10 minus 38 gives me minus 28. And that's a good sign. I'm very pleased with that because I know that 28 is in the 7 times table. So that means y must be equal to minus 4. And what I've done is I've divided both sides by 7 to get that. So that's my first number. Now to get my second number, I'm going to take y equals minus 4, and I'm going to substitute it. And I'm going to substitute it. It doesn't matter which one. I'm going to leave for the first one. 4x plus y equals 10. So 4x, but y is minus 4, so that's minus 4. Add the 4 over. 4x is equal to 14, which means x is equal to 14 divided by 4, which is 7 over 2, or 3.5 if you'd rather. Now, a little bit suspicious. I got that from this one here, so now I'm going to put both of these numbers into this one just to double check that I'm right. So 2 times 3.5, because that's what x is, minus 3 times y, but y is minus 4. And 2 times 3.5 is 7. Minus 3 times minus 4 is positive 12, and that's going to give me 19, which is what I've got here, which gives me a good sense of inner peace about my correctness.